In section 8.1, we're looking at quadratic equations. The first thing we're going to talk about is the square root property. This says that if x squared is equal to a, then x equals plus or minus the square root of a, for all real numbers a. So the goal is to get the part that is squared by itself on one side so that you can take the square root of both sides and essentially cancel the square out. The big thing you have to remember when using the square root property is to put plus or minus in front of the square root. So for the first example, we have 3x squared plus 2 equals 77. Your notes say 75, it should say 77. So the goal is to get the x squared by itself. So the first thing we're going to do is we're going to subtract 2 from both sides. And so it's going to cancel on the left. We have 3x squared equals 75. Still trying to get x squared by itself, we're going to divide both sides by 3. And so it ends up canceling on the left, and we get that x squared is equal to 25. To cancel out the square, we are going to take the square root of both sides. On the right-hand side, we want to make sure we put that plus or minus. And so on the left, the square and the square root cancel, and we just get x. And on the right, we have plus or minus 5. Let's go ahead and try another one. We have 4x squared equals negative 16. So we want to get the x squared by itself. So I'm going to divide both sides by 4. So it cancels on the left. And we get that x squared equals negative 4. And so now that the x is by itself, we're going to take the square root of both sides. So we have the square root of x squared equals plus or minus the square root of negative 4. And so on the left, we just get x. And on the right, this is going to simplify as plus or minus 2i. Remember, the negative underneath the root comes out as an I, and the square root of 4 is just 2. You can always plug your answers back in and check them in the original, and you should get a true statement. Let's try example number 3. We have 4x minus 1 squared equals 5. Now, although this looks a lot more complicated, the squared portion, which is the 4x minus 1, is already isolated on the left-hand side. So we can automatically just take the square root on both sides. So we get the square root of 4x minus 1 squared equals plus or minus the square root of 5. And so on the left, the square and the square root cancel, and we're just left with the 4x minus 1 equals plus or minus the square root of 5. And now we're just solving for x. So we can add 1 to both sides. Now make sure you don't add the 5 and the 1 together. You can't do that because the 1 is not underneath the radical. And so we get 4x equals 1 plus or minus the square root of 5. And then the last thing we can do is divide both sides by 4. So we end up getting x equals 1 plus or minus the square root of 5 all over 4. The next method we want to talk about is completing the square. So the first thing is we're going to put the equation in the form ax squared plus bx is equal to c. If a is not equal to 1, we're going to divide each term of the equation by a. We are going to square half of the numerical coefficient of the linear term and add the result to both sides of the equation. The way that I like to denote this is b over 2 squared. We're going to factor the left side, then take the square root of both sides of the equation, solve the resulting equation for x, and then check the solutions in the original equation. So looking at example number 4, we have 3x squared minus 8x plus 1 equals 0. The first thing we have to do is make sure that the variables are isolated and the constant is on the other side. So we're going to subtract 1 from both sides of our equation. So it ends up canceling on the left, and we get 3x squared minus 8x is equal to negative 1. The next step says that if the leading coefficient a is not equal to 1, we need to divide each term of the equation by a. Well, a in this case is 3, so we are going to divide every single piece by 3. So we have x squared minus 8/3 x equals negative 1/3. We need to now figure out what b over 2 squared is so we can add it to both sides of the equation. Well, our b is negative 8/3, and we're going to divide that by 2. We're going to use keep, change, flip so that we can simplify inside the parentheses first. So we're going to keep negative 8/3, change the division to multiplication, and flip the denominator into 1/2. So multiplying across the top and the bottom, we end up getting negative 8 over 6, which can be simplified as negative 4/3. And so squaring the top and bottom, we get 16 over 9. That is what we are going to add to both sides of our equation. So we have x squared minus 8/3 x plus 16 over 9 equals negative 1/3 plus 16 over 9. So the reason why we do this is because the left-hand side is now a perfect square trinomial that can be factored nicely. And so to factor this, the way we set this up is we're going to have our parentheses with our x, and it's going to be squared. To figure out that missing number, you're going to go back down to when we were looking at b over 2 squared. Whatever the simplified version is before you squared it is what the number will be inside the parentheses. So in this case, -4/3. And on the right-hand side, we need to have a common denominator so that we can add these two things together. So our LCD is 3. Our LCD is 9, so we're going to multiply this first term by 3 on the top and bottom. So we get x minus 4/3 squared equals, the right-hand side is going to turn into 13 over 9. And so now we have our piece squared by itself, so we can go ahead and take the square root of both sides using the square root property we just learned. As far as the right-hand side goes, I'm going to split my fraction into two separate square roots. So I'm going to end up with plus or minus the square root of 13 divided by the square root of 9. And the reason why that I do this is because we're going to have to rationalize the denominator anyway. So we end up getting x minus 4/3 on the left, and on the right we have plus or minus. We cannot simplify the square root of 13 on the top, but we can simplify the square root of 9 on the bottom, which just gives me 3. And now to solve for x, we just want to add 4/3 to both sides. So we have x equals 4/3 plus or minus the square root of 13 all over 3. And these two terms already have the same denominator, so we can just smush it together into one fraction. So we get x equals 4 plus or minus the square root of 13 all over 3. Let's go ahead and try one more. We have m squared minus 7m minus 1. The first thing we want to do is to make sure our variables are isolated. So we are going to add 1 to both sides to do this. So we get m squared minus 7m equals 1. Now in this case, the leading coefficient a is 1, so we don't need to divide all of the terms. We just need to figure out what we're going to add to both sides now. And so that's when we look at b over 2 squared. Well, our b in this case is -7. And since this inside can't be simplified anymore, we can just square the top and bottom, and we end up getting 49 over 4. So that's what I'm going to add to both sides of my equation. I have m squared minus 7m plus 49 over 4 equals 1 plus 49 over 4. Now that we've done this, the left-hand side is going to factor nicely. Remember, we set up our parentheses, and we go back to our b over 2 squared to figure out what we're going to plug into our blank spot. In this case, it's negative 7/2. On the right, we need to have that common denominator, which is going to be 4. So I'm going to multiply this first term by 4 on the bottom and top. So we have m minus 7/2 squared is equal to 53 over 4. Again, I have my piece squared by itself, so we can take the square root of both sides. Again, I'm going to split my fraction into 2 separate square roots because I'm going to have to rationalize the denominator anyway. So the left-hand side, the square and square root cancel, and we just have the m minus 7/2. And on the right, we still have our top of plus or minus the square root of 53, since that cannot be simplified, but the bottom we just end up with 2. And so to get m by itself, we're just going to add 7/2 to both sides. So we end up getting m equals 7/2 plus or minus the square root of 53 all over 2. And again, we have the same denominator, so I can just smush this as one fraction. We've got m equals 7 plus or minus the square root of 53 all over 2.